how to handle this situation. Stationary lift, and inside it you have a box. We put it on the scale, and we want to know the scale reading right now. What is the scale reading? We know that we have to apply this formula somehow, but we don't know where to start. Okay, first there are two forces acting on the box. The first one is weight, and according to the Newton law, there must be a force reacting to weight in an opposite direction. So we name it, we call it R, normal. Based on this formula, we know that the right hand side must be equal to 0 because the lift is stationary and our acceleration is equal to 0. So everything, the sum of all forces must be equal to 0. And then we consider our weight, or mg, as negative and our r as positive. So r minus mg equal to 0. So r equal to mg. So this is the equation that we want. In this situation, the scale reading is r. Now the lift is accelerating upward, so we know that our acceleration must be equal to some value, but we don't know. We just want to write a relation between all of the forces acting on the object. As usual, we want to apply this formula. The sum of all forces must be equal to ma. Consider our lift is accelerating upward, so our right hand side cannot be equal to 0. So everything on our right hand side must be equal to ma. And now since the motion is upward, the same direction as r, so we consider r as positive and our weight as negative. So we can simply write it as F minus mg. Okay, it's not r, it's not F but r. R minus mg equal to ma. So we bring everything to the mg to the right, so our r equal to ma plus mg. Our r is the scale reading. We need to compare with our own experience in a lift. When the lift is moving upward, accelerating, we feel slightly heavier. So this is the answer is justified. R equal to ma plus mg. It does make sense because we do feel slightly heavier in the lift when the lift is moving upward. Now the situation is the lift is moving downward, accelerating, and we want to know what is the scale reading. Okay, we want to apply this formula. The sum of all forces must be equal to ma, because a, we have must not be equal to 0. We have a certain value. A has certain value, so everything on our right hand side must be equal to ma. It cannot be equal to 0. so we write it as ma. And now we want to consider all the forces acting on the object r and our weight. Now here is the tricky part, because the motion is downward, the same direction as our weight, so we consider our weight as positive, not to be confused with previous situation. It's actually the same thing, we just we consider weight as positive because the direction of weight is the same as the direction of motion, because r is in the opposite direction, so we consider it as negative. So negative r plus mg, so we bring r over here to make it positive r, and then mg minus ma. So the reading will be slightly smaller compared to two previous situation. Compare it with our real life experience, we do feel slightly lighter when the lift is moving downward, accelerating downward. So here it is, the relationship between mg, ma and r.